Hi class, let's do some more linear algebra. Today we're going to talk about type 2 elementary matrices. Generally speaking, a type 2 matrix is one that scales a row by a scalar, a real number. And if we're going to scale row I in particular by some real number, some non-zero real number, then the type 2 elementary matrix that does this will look like so. It'll have ones down the diagonal, except there's going to be an alpha in row I. This matrix is 0 elsewhere. Let's talk about the determinant of type 2 matrices. For this, let's turn the page. Claim 15. Say E2 is an n by n elementary matrix of type 2. In particular, it will scale row I by some non-zero real number. If A is an n by n matrix, some other matrix, then the determinant of E2 times A is equal to alpha times the determinant of A. In plain language, this means that scaling a row by alpha, a single row by alpha, it will scale the determinant by alpha. As a result of this, we have an additional part of the claim that the determinant of the matrix itself, E2, is alpha. Let's prove this. Proof. We're going to find the determinant of E2A by expanding along the scaled row. The determinant of E2A is going to be the sum along the scaled row. So originally we would have AIK times big AIK using the scaled row, which is the ith row. However, we've multiplied through the ith row by alpha. So in the ikth spot, we're actually going to have the entry alpha times ik, as k ranges from 1 to n. Since alpha is some real number, we can pull this out. And this is just simply the formula for alpha times the determinant of A. Now, let's think about what we've just proved, but particularly for A is equal to the identity matrix. Notice the determinant of E2 is going to be, of course, the determinant of E2 times the identity matrix. By what we've just proved, this is going to be equal to alpha times the determinant of the identity matrix, which is alpha times 1, which is alpha. QED, end of proof. Let's do an example. Say A is equal to the matrix A, B, C, D. And say for some reason we knew that the determinant of A is equal to 3. Then what would be the determinant of 2A, 2B, 3C, 3D? Let's work through this. Notice the first row is scaled by a 2, and the second row is scaled by a 3 from our original matrix A. Scaling a single row scales the whole determinant by that same scalar. So in particular, the determinant of this matrix here is going to be 2 times the determinant, where we've factored out 2 from the matrix. We can do the same trick again. The last row is scaled by 3. This should scale the determinant. And we know what the determinant of A, B, C, D is. By assumption, it is also 3. 2 by 3 by 3, 2 by 9, 18. Here's an exercise for you. If A is equal to, again, A, B, C, D, and for some reason we knew that the determinant of A is 2, then find the determinant of 4A, 4C, B, D. Hint? Recall what happens when we take the transpose. How does this change the determinant? Next up, type 3 matrices. See you next time.